welcome to another session on dot discussion and math problem solving. Today's topic is from trigonometry, and the question is a proving type question, which is cos to the power of 4 theta minus sine to the power of 4 theta equals to 2 cos square theta minus 1. All right, and in a proving type question, all you have to do is to work on the left-hand side of the equation and then work it all the way down so that, it finally appears completely like the right-hand side. And then you make certain changes to the left-hand side to make sure that what you end up with is exactly like the term on the right side. So here I'm going to start working with the powers. That's cos raised to the power of 4 and sine raised to the power of 4. I can write cos to the power of 4 as cos square theta raised to the power of 2. Because if I multiply this 2 inside over here, it's going to give me back cos to the power of 4 theta. And same I can do with sine to the power of 4 theta. I can write it as sine squared theta raised to the whole power of 2. Now, if you look at the question, if you look at the expression on this side, it's cos to the power of 4 theta minus sine to the power of 4 theta. That means if you write cos to the power of 4 theta as cos squared theta whole power 2 minus sine squared theta whole power 2, it looks something like a square, all right, and then b square. Now here we're going to make use of that algebraic expression, algebraic formula that is a square minus b square. And a square minus b square is nothing but a plus b and a minus b. Now you need to figure out what the a and b is in the expression. So we can clearly see that a square is actually cos to the power 2 theta. And b square is sine to the power 2 theta. Plug in these values in this algebraic equation. Plug in the values in this equation. This one. What you're going to get? You'll get cos square theta minus sine square theta. And then you're going to get a cos square theta plus sine square theta. Now, we should know that cos square theta plus sine square theta equals 1. It's a trigonometric identity, and the derivation of this thing would be a topic for another class. But right now, we're going to write this as 1 and then multiply it with the whole thing here. Now, there is a smart thing to do. Have a look at the sine square theta. All right. At this step, we're going to convert the sign in terms of cos because the right side of the question has got no sine term. And that's the only logical thing to do, to convert the sine squared theta into something that is cos. So we're going to make use of this formula right here and flip the cos, toss it to the right side. So you're going to get sine squared theta equals to 1 minus cos squared theta. I hope I'm clear till now. All you need to do is to plug in the value of sine squared theta over here. So you'll write cos squared theta, put the minus, open a bracket, a parentheses, and put 1 minus cos squared theta in here. Be careful with the signs. And then open the bracket. So you'll get cos squared theta minus of 1, and when you multiply this minus over here, you get minus times minus plus cos squared theta, and then the whole thing is multiplied with 1. Add up the like terms, so you'll get cos squared theta plus cos squared theta. That's going to be 2 cos squared theta minus 1. And yes, this looks exactly like the term on the right side. Hence proved.